All right, so let's look at this right here. We're going to find the volume of a cube. All right, and volume is the side length cube. All right, just kind of how area is side squared. All right, comes from a square. Side cube comes from a cube. All right, so volume equals 1 cube, which equals 1. All right, the side length of 1. All right, the volume of a cube with side length 1 is just 1. And it'd be centimeters cubed. Sometimes I don't put units. All right, here, all right, this is going to be a punch line. Notice how the side lengths get twice as big. All right, the scale factor is 2 just for side lengths. But notice that if we do 2 cubed, we don't double the volume. It got 8 times bigger. Oh. Well, kind of ignore units. Those aren't important for this. All right, we went from 1 to 8. Okay. Notice if we make the sides 5 times bigger, the volume is 5 cubed, which is 125. Wow. All right. In this one, we're actually, scale factor is 1/2. Okay, so the volume is 1/2. Plug it in like this to Desmos. All right, it'll ensure that it's cubing the whole fraction, and you get 1/8. All right, so that was pretty cool because we reviewed volume for a cube, and then we saw that the scale factor for sides does not match the scale factor for volume. All right. So developing a rule, all right, scale factor, we use K. All right. We have scale factor. Okay, when we do it for sides, all right, when you're making a sides, actually, let me do this, timeout. And I'll put parentheses perimeter, because perimeter is just side lengths added together. That's K. Scale factor for area, okay, this is 2-dimensional. All right, so if you think about it, you're making the scale factor bigger in length and width. Remember, it was K squared. All right, just how the area is squared, your scale factor will be squared. And then we have scale factor for volume, which is 3-dimensional, and that's K cubed. All right, you have length, width, and height that you're all dilating by a scale factor, so then when you do it for volume, it's K cubed. All right. And here, again, repetition, I wrote that out, but then we have a nice table of its summary of what I just did. Okay, I'm a firm believer in repetition. All right, so we have all of that cool stuff right there. Remember, it's a good idea to maybe pause the video. Make sure you have all this written down. Maybe you listen, pause, write it down. Listen, pause, write it down. Okay. And just looking at this for fun right here. All right, if we match up these two sides, you can see K is 3. Cool. For fun, because math is fun. If we did this, those faces right there, the area of just those squares would be 4 times 5 over here, which is 20. Or over here would be 12 times 15, which is 180, which those scale factor. That increased by 9 because we did area. All right. And then if we did the volume, this is going to be crazy. 4 times 5 times 3, which is 60. Okay, over here we get 12 times 15 times 9, 900. I think it's something like that. Double check. 12 times 15 times 9. Got it right. And that's K cubed, which would be 27. All right, the volume got 27 times bigger. All right, that's the front page. Next video will be the back page.